So when this problem says distance, you guys could also think height, okay? Remember we were measuring the height of the car on our Ferris wheel. And so if I draw a little diagram right here would be where the car is on our Ferris wheel. You guys remember it had like a little circle right here? It's like, wee. Okay, that's our Ferris wheel. This is 30 degrees. That's the height of it. Where would be an equal height from the midline? And this is 30 degrees, and you guys said it was, so it has to be equal height right here. It would be right here, right? Wouldn't it? What would be this angle? And some of you guys are thinking right now, and you're not quite sure. This is how you should think about it. What is the angle measure if I go all the way to here? 180 degrees. So if this is 180 degrees, what would this be right here?
30.
That's 30. So what would this be right here?
50.
Yeah, so the measure for that angle is 150 degrees. So this is 30, that's 150, and they both give you the same height. Yeah? Yeah. Okay. So you look at that as 180. They both give you the same height. Okay, so now this next question says, which angles give us the opposite distance than 30 degrees? So if this is h, that's the distance right here, the height. The opposite would be going down, right? We would have a negative h. What would be the degrees for those points? Okay, let's talk about this first one right here. What would be the degrees for this? So starting right here, what's this angle going all the way to that? Start at 180. Whoop. This is 180, right? And if I want to go this far away, how many more degrees is that?
30.
30, so 30 plus 180 is? 210 degrees. Okay, maybe you guys are with me, maybe you're not. Hopefully you are. Now let's look at the other point. The other point is right here. What would that one be? This would be the opposite distance than the 30 degrees one. You guys know what angle this is?
330.
Yeah, 330. You go to 360 degrees, subtract 30, you get 330. So these guys right here all give us the same height, just about, almost. They're all related. And so let's change our thinking now for a second. We were thinking in degrees. Now let's think in radians really quick. I actually think that radians is a lot easier to think in than it is to think in degrees. So if this is pi over 6 right here, what would be the measure of this angle right here that gives us the same height? Think about it with your neighbors. Go. Yeah, very nice. Okay, so if you guys know that all the way, like from here all the way to here to the 180 degrees angle, you know what I'm talking about, is pi, isn't it the same as 6 pi over 6? 6 pi over 6 is pi. And I'm thinking 6 pi over 6 because this one has a denominator of 6. So what would be the measure of this angle right here? That would be 5 pi over 6 because you're going to back up 1 pi over 6 to get to that. Does that make any sense to you? Okay, so that gives me the same height. What would give me the opposite height?
7 over 6 and 11 pi.
Yeah. So you're going to think 6 pi over 6, right? And then you're going to go up one more. So what is 6 pi over 6 plus pi over 6? It'd be 7 pi over 6. Very nice, very nice. So what about this last one right here? What would that one be? If you went all the way around, what would all the way around be with the denominator of 6 in radians? 12 pi over 6. And so we back up 1, it would be 11 pi over 6. So these guys right here are all related also to pi over 6. Okay, so we can say, therefore, which angles in the circle may we say are related to 30 degrees? We can say that 150, 210, and 330 are all related to 30 degrees. There's actually more, but I'm just staying within one rotation, 1 degrees rotation. What about the pi over 6? Which angles would be related to him? You would say 5 pi over 6, you would say 7 pi over 6, and then 11 pi over 6. Now all these angles have something in common. Like these guys have this dude in common, and these guys have this dude in common. So 30 degrees and pi over 6, those are special angles. It has a special name. We go down to here, 30 degrees is called a blank angle. Write in reference. 30 degrees is a reference angle. It's a common angle that we reference to find information about other angles in the circle. And the same goes for pi over 6. So for the reference angle, 30 degrees, what is the angle in the second quadrant that has a reference angle of 30 degrees? And y'all would say 150 degrees. If you're in quadrant 3, okay, you guys remember quadrants? This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Okay, in quadrant 3, what would be the angle measure? 210. And what would be an angle measure for quadrant 4? 330 degrees. And then we also have the radians. For radians, this one would be 5 pi over 6. This one right here would be 7 pi over 6. And then the last one would be 11 pi over 6. Those all these angles have these two dudes as reference angles.